In question number 2, I'm asking you to find all 6 trig function values for the angle theta. So we start off with that picture. We're going to look at our angle theta, and here's theta. We know our side that is. Opposite, we know the adjacent. So opposite, adjacent, we can get the tangent right away, but we might as well find the hypotenuse here, and we can find that hypotenuse, or C, if we apply a Pythagorean theorem. Remember, it's in play because we have a right triangle, so that means C squared has to equal 5 squared plus 4 squared. That means C squared has to equal 25 plus 16. That means C squared has to equal 41, which means the value of C is the square root of 41. So now we know our opposite side of the hypotenuse is 41, or the square root of 41. Clear that up. So I can keep referring back to the picture. I'm going to put it on that side length, and now we're going to go grab those values. So the first one we need is the sine of theta, which is 5 over the square root of 41. Remember to rationalize, so it's going to be 5 square roots of 41 all over 41. We're going to reciprocate this ratio to get the cosecant, which is the square root of 41 over 5. The next one we're going to do is a cosine. The cosine is the adjacent over the hypotenuse, so it's going to be 4 over the square root of 41. Grab different colors so you can see them. So it's 4 over the square root of 41, which is equal to 4 times the square root of 41 over 41 if you rationalize. And then the secant is the reciprocal of that trig function, so it's going to be the square root of 41 all over 4. And now we're going to grab our tangent, and the tangent is opposite over adjacent. So there's your opposite and adjacent of the angle, so it's 5/4, and cotangent is reciprocal of that, which is 4/5. Okay, and in the second one, in part B, what we have is something just a little bit different. They tell us a trig ratio is sine of theta is 8 over 17. So sine of an angle is always your opposite side, which is 8, over your hypotenuse, which is 17. So we know that 17 squared would have to equal 8 squared plus some other number squared. I'll just call it b. So I'm going to find that other leg by taking our 17 squared. 17 squared is 189. 8 squared is 64 plus b squared. To solve this for b, I got to subtract the 64. So 189 minus 64, that seems to be, I better go check that. I better check 17 squared too. So 17 squared, I got to make sure I have the right number on that one. Okay, I had part of it right. It's 289, and then we're going to subtract from that 64. Okay, so I had a little brain melt here. This is 289. We're going to subtract the 64, and that gave us 225. And we got to take the square root of that. So that means b, getting a little messy here, I'm going to come up here. b is equal to 15. If I take the square root of 225, which is the same thing as raise it to the 1/2 power or the 0.5 power, you can see that it's 15. So now I have all the missing pieces. I know that this side b down here is 15. So now let's go grab all the ratios that we need. The sine is the opposite, which is 8 over 17. Sorry, I'll get a color you can see. 8 over 17. The cosecant is reciprocal, so 17 over 8. The next one is our cosine, which is the adjacent, which is 15 over the hypotenuse. Reciprocate that, 17 over 15, you have your secant. The tangent is the opposite, which is 8 over the adjacent, which is 15, and the cotangent is a reciprocal of that. So 15/8. So that's how we should proceed through the questions in problem 2. Use a little bit of Pythag along with your SOHCAHTOA because they are right triangles. Those are both available.